Hello, and a very warm and gentle welcome back to the Midnight Scientists. I am so glad you could join us again here in this quiet place. Here we do not rush, we do not strive for answers. Instead, we gently explore the grand, silent tapestry of the universe, one slow, soft breath at a time. Tonight, we are embarking on a very peaceful, very soothing journey, a slow drift to the very edge of one of the biggest yet softest questions we can ask. Where does space stop? It is a question that feels simple at first, isn't it? It has a childlike wonder to it. You might have asked it, staring up at the stars on a clear night, feeling very small and very curious. But as you allow yourself to sink into it tonight, as you let it rest in your mind not as a problem to be solved, but as a gentle mystery, you will feel it begin to stretch your mind, expanding your sense of scale, your sense of possibility, much like the universe itself. As always, my deepest hope is that this journey helps you to untether, to gently unclip from the day's worries and responsibilities. Imagine them as little balloons, and with each breath out, you are letting one go, watching it drift away into a vast, peaceful sky. This journey is an invitation to drift off with them into a deep, peaceful, and truly restorative sleep. Or, at the very least, I hope it helps you place those worries into a much grander perspective. Sometimes the best way to see how small our troubles are is to zoom out. Not just a little, but to pull back, past the clouds, past the moon, past the edge of our solar system, and to keep going for a few billion light years. From that quiet, distant vantage point, the things that felt so heavy today can seem as light as dust motes dancing in a sunbeam. There is, of course, the small and rather wonderful risk that you might find this all too interesting, that the gentle unfolding of the cosmos might keep your mind softly engaged. And if that happens, that's perfectly all right. At least you will have learned something wondrous to dream about when sleep does finally arrive. Before we float off into the cosmos together, if you feel so inclined, I would be so grateful if you gave this video a like, and perhaps even subscribed if you haven't already. It is a quiet, simple act that truly does help this sleepy little channel grow, helping us reach other curious minds in other quiet rooms all across the globe. And on that note, I would love to know where you are listening from. What time is it in your small corner of our beautiful world? Let me know in the comments. Are you nestled in a cozy bed in Stockholm as the city quiets and midnight approaches? Or perhaps you are listening from a comfortable couch in Melbourne, with the warm afternoon sun slanting through the window as you pretend to work. It is always such a quiet joy to read those comments, to imagine our community of sleepy scientists scattered so gently across the planet, all looking up at the same grand sky. Now, though, it is time to let all of that go. Find your most comfortable position. the one where your body feels truly supported, truly at ease. Go ahead and make any final adjustments, a wiggle of the toes, a repositioning of your pillow. Let your muscles begin to soften. Start with the small muscles around your eyes. Feel them release. Allow your jaw to unhinge slightly, releasing any tension you might be holding there. Let that feeling of softness flow down your neck and into your shoulders. Feel your shoulders grow heavy, sinking down away from your ears. Let your breath find its own easy, natural rhythm. There is no need to control it. Simply notice it. Notice the gentle rise and fall of your chest or your belly, a slow, steady, quiet rhythm, like the tides of a calm, distant sea. You don't need to remember any of this. There will be no test at the end. Simply let the words and the ideas wash over you, like the faint, ancient light of the cosmic microwave background, a gentle hum that fills all of space. And as we begin this gentle voyage into the vast, quiet unknown, please remember this. This video is for educational and relaxation purposes only. It is not intended as medical advice or a substitute for professional care. Are you ready? Let your breath be your anchor, and let us begin. Let us start with the most basic of questions. What exactly is space? That silent, black canvas we see when we look up at the stars? That deep, velvety darkness between the points of light? What is it really? For most of us, we think of space as nothing. A void, an absence, a vast empty stage where stars float like dust motes, where planets perform their silent orbital dance, and perhaps where lost socks from the dryer mysteriously vanish to. But space, as it turns out, is anything but empty. In fact, it is one of the most active, mysterious, and deeply misunderstood fabrics of our reality. To truly appreciate what space is, let's drift back in time for a moment. For many, many centuries, brilliant minds pictured space as a simple, unmoving backdrop. Imagine an old wooden stage in a grand, silent theater. The stage itself is absolute, fixed, and unchanging. Space was seen as this flat, rigid floor. And on this stage, the planets and the stars were the actors, moving across its surface according to fixed, predictable rules. This elegant clockwork idea came to us from the great Sir Isaac Newton. In his universe, space was absolute, an infinite, unchanging arena in which the cosmic drama unfolded. Time, in his universe, was also absolute. It ticked along at the same steady, relentless pace for everyone and everything, everywhere. Space was simply the three-dimensional grid that held it all together, a perfect, invisible, and passive container. It was a comforting thought, a universe that was orderly, predictable, and solid. Then along came a gentle soul with a wild imagination, a man with famously untamed hair and the habit of scribbling on chalkboards, Albert Einstein. With his theories of relativity, he took that tidy, static image of space and gently turned it inside out. He replaced it with something far more strange, far more elegant, and far more alive. According to Einstein, space is not a passive backdrop at all. It is not a container for reality. It is a part of reality. He realized that space is a dynamic, flexible fabric, one that can bend and twist and warp in the presence of mass and energy. He revealed that space and time are not two separate things, but are intimately, inextricably woven together into a single four-dimensional construct he called spacetime. And this stage, this fabric of reality, actively responds to whatever is happening on it. The dancers shape the floor, and the floor guides the dancers. To feel this in your mind, let's use a beautiful and simple image. Picture a large, perfectly circular trampoline stretched out in a vast, dark, and silent space. The black fabric of the trampoline is stretched perfectly taut, perfectly flat. This represents the fabric of spacetime. Now, in your mind's eye, imagine placing a heavy bowling ball right in its center. Don't let it drop, just place it there gently. Watch as the fabric sinks under the weight, creating a deep, smooth, curved well in the center of the trampoline. This dip, this gentle curvature, is precisely how space-time behaves around a massive object like a star or a planet, or even your own body, just on a much, much smaller scale. Now imagine you are holding a small, cool, smooth marble. Gently roll it across the trampoline's surface, aiming just to the side of the central bowling ball. If the trampoline were perfectly flat, the marble would travel in a perfectly straight line. But it doesn't, does it? Instead of moving straight, the marble's path gently curves as it passes the bowling ball. It is drawn into the dip, its trajectory altered by the curve in the fabric. It might even begin to circle the bowling ball, caught in a stable orbit. That is gravity. Massive objects like our Sun and our Earth are bending the fabric of space-time around them, and that curvature is what we perceive as the force of gravity. You are not being pulled down into your bed right now by some invisible, mysterious rope. You are simply resting in the tiny, gentle curve in space-time that the Earth's immense mass has created. You are like the marble following the path of least resistance along a curved surface. Gravity isn't a force, it's a feature of the geometry of the universe. It is the shape of space telling matter how to move. Let that idea settle for a moment. The very space around you, the space you are moving through, is not empty. It has shape. It has texture. It is a real physical thing that can be bent and warped. You are nestled in it right now as you breathe. Now you might be thinking, all right, I can feel how space bends around a planet or a star. But what about the great dark gaps between them? The vast, silent voids of intergalactic space. Surely that is just nothing? It is a natural thought. From our quiet vantage point, these regions look like the definition of emptiness, a perfect, featureless black. But the universe, in its quiet and profound way, is always more intricate than it first appears. Even in the darkest, most solitary corners of the cosmos, far from any galaxy's glow, space is humming with a secret, vibrant activity. Thanks to the strange and wonderful rules of quantum mechanics, we now understand that empty space is not truly empty at all. To understand this, we have to zoom in, way, way in, far smaller than a grain of sand, smaller than a single cell, smaller than an atom. At the smallest scales imaginable, a level of reality so fundamental it's hard to even picture. Space is buzzing with what physicists call quantum fields. Now, try not to think of these fields as things in space. In a very real and beautiful sense, these fields are space. Imagine that every fundamental particle in the universe, the electron that orbits an atom, the photon of light that travels from a star, the tiny quarks that make up protons and neutrons, is not a tiny solid ball. Instead, each one is just a tiny, localized vibration, a plucked string in its own corresponding field that extends everywhere throughout the universe. There is an electron field, a photon field, and so on, all layered on top of each other, all interpenetrating, all filling the entirety of space-time. The universe, at its core, is a symphony of these vibrating fields. And even when no particles are present, even in what we would call a perfect vacuum, these fields are never completely still. They can never be perfectly flat, perfectly zero. They fluctuate, they shimmer, they seethe with a quiet, restless, inherent energy. To picture this, imagine you are looking out over a vast, deep, and perfectly calm pond at dusk. From a distance, its surface appears as smooth as glass, a perfect mirror of the darkening sky. It looks completely still, completely at rest. But now, imagine you could get very, very close. So close that you could see the individual molecules of water. From this impossibly close perspective, the surface is not still at all. It is a trembling, jittery dance of constant motion. Tiny ripples appear from nowhere and vanish just as quickly. The surface is alive with a hidden, simmering energy. This is what empty space is like. What seems featureless and empty from our grand human scale is in fact alive with a constant simmering potential. This jittery energy in so-called empty space is known as vacuum energy. This constant fluctuation of the quantum fields is always producing tiny, momentary pairs of particles. They flicker into existence from the underlying energy of space itself, exist for an impossibly short moment, and then annihilate each other, returning their borrowed energy back to the void. They are like cosmic fireflies on a warm, infinite summer night, a constant silent flickering in the dark. These fleeting pairs of particles, known as virtual particles, cannot be seen or captured directly. Their existence is too brief, but we know they are there because we can measure their effects. They subtly influence the behavior of atoms and are thought to be the mysterious driving force behind something we call dark energy, the very energy that is causing the universe to expand faster and faster every second. The quiet hum of the void pushing everything apart. So, no, space is not an absence. It is not a void. It is alive with geometry and movement. It can bend and stretch. It can expand and ripple. It even has a temperature. The vast emptiness between galaxies is not absolute zero, the coldest possible temperature. It is a chilly but very real 2.7 Kelvin, a few degrees warmer than absolute zero. It faintly glows with the leftover heat from its own creation, the residual warmth, the cosmic afterglow of the Big Bang. When we ask, what is space? We are not talking about an empty container. We are talking about a rich, structured, dynamic entity that connects every galaxy, every star, every atom, and every one of us. Space is not just where things happen. Space itself is one of the things that is happening. And as you drift here in the quiet of your room, perhaps it's comforting to know that even in the quietest, darkest moments, there is still this soft cosmic hum, this gentle, constant shimmering, a beautiful reminder that we are part of a universe that is never, ever truly empty. Just rest in that thought for a moment. Feel the gentle, vibrant stillness all around you. Now, imagine yourself standing on a quiet hilltop, or perhaps simply floating, weightless, in the deep, comfortable darkness. You gaze out at a universe that seems to stretch in every direction, forever. It feels endless, infinite, eternal. Tiny points of light scattered across a boundless velvet cloth. But what if I told you there is a cosmic limit to what you can see? Not a wall or a barrier, but a gentle, shimmering boundary. A kind of celestial bubble that surrounds us, not because the universe ends there, but simply because light, the patient messenger of the cosmos, has not had enough time to reach us from beyond that boundary. This is the observable universe. It is the portion of the cosmos we can actually detect. The light, the radiation, the gravitational waves that have managed to complete their long, long journey to us since the very beginning of time. That word, observable, is the key. It doesn't mean that nothing exists outside of it. Far from it. It just means we are not yet fortunate enough to have seen it. It is our cosmic neighborhood, the part of the story we have received so far. And here is where our minds get to stretch in a truly wondrous way. You might logically think that since the universe is about 13.8 billion years old, the farthest we could possibly see would be 13.8 billion light years away. Light travels at the speed of light, so that should be the edge of our vision, right? If only the universe were so simple, so static. The reason it's much larger is because the very fabric of space, the stage itself, has been expanding the entire time that light has been traveling. The observable universe, the bubble of light we can currently see, has a radius of about 46.5 billion light years in every direction. This makes the whole thing a staggering almost incomprehensible 93 billion light years across. How can this be? How can something be farther away than its age in light years? Let us return to one of our favorite and most comforting analogies: the raisin bread. Imagine in your mind a large loaf of unbaked dough. It is soft and pliable. Now you place little raisins all throughout the dough. These raisins represent the galaxies. You place the loaf into a warm, gentle oven. As the bread bakes, the dough begins to rise. It expands, gently and uniformly, in every direction. Now, focus on one single raisin, somewhere in the middle. From its perspective, all the other raisins are moving farther away from it. A nearby raisin moves away slowly. A raisin on the far side of the loaf recedes much more quickly. There is no center to this expansion. It's happening everywhere at once. The raisins aren't crawling through the dough. They are being carried along by the stretching of the dough itself. Now, imagine a tiny, magical firefly sitting on one raisin. Just as the baking begins, it sends a single, tiny pulse of light toward another raisin far across the loaf. That little photon of light begins its journey, traveling through the dough toward its destination. But while it is traveling, the dough itself is still expanding. The space between the firefly's raisin and the destination raisin is stretching. The little photon of light has to travel across a distance that is constantly growing. By the time that little pulse of light finally arrives at its destination raisin, the bread has expanded significantly. The destination is now much, much farther away than it was when the light first began its journey. This is exactly what has happened on a cosmic scale. The light from the most distant galaxies we can see has been traveling for nearly 13.8 billion years. But during that immense span of time, the very fabric of space between us and that distant galaxy has continued to stretch and stretch and stretch, carrying that galaxy much, much farther away from us. This brings us to the gentle concept of the cosmic horizon. This isn't a wall. You won't fly a spaceship out there and bonk into the edge of the universe. It is something much softer, much more subtle. It's more like the horizon you see on a very foggy day. Imagine standing in a quiet field, enveloped in a thick, soft mist. You can see the trees and objects nearest to you quite clearly. A little farther away, they appear as faint, gray silhouettes. And beyond a certain distance, you can see nothing at all. Not because the world ends there, but because the light from anything farther away is scattered and lost in the mist before it can reach your eyes. The world just gently fades from view. Our cosmic horizon is like that. It is a horizon in time. Beyond this boundary, light from distant regions simply has not had enough time in the entire 13.8 billion years history of the universe to complete its journey and reach us. It's as if we're standing in a vast, quiet mist of time, only able to see the glow of the nearest cosmic lights. The rest is shrouded, not because it isn't there, but because its signal is still on its way. This horizon is always changing. As time marches on, light from ever more distant regions will finally arrive, and our observable bubble will slowly grow larger. But at the same time, a strange and poignant cosmic drama is unfolding. Due to the accelerating expansion of space, driven by that mysterious dark energy,
Some of the most distant galaxies are now moving away from us so quickly that the light they emit today will never, ever reach us.
They are receding faster than light, not because they are breaking any cosmic speed limit by flying through space, but because the very fabric of space between us and them is stretching too fast for light to overcome. In a very real and very gentle sense, parts of the universe are slipping out of our grasp, their future light lost to us forever. They are becoming part of the universe that is unobservable. Let us pause and appreciate something beautiful. Every single star, every galaxy, every faint smudge of light we can see in the night sky is nestled within our own personal, observable universe. That is the good news. The humbling news is that there is almost certainly far more beyond it, perhaps infinitely more, that we will never see, touch, or study. And what's even more humbling is that every observer everywhere in the cosmos has their own unique observable universe. An astronomer on a planet in a galaxy 10 billion light-years away would have a cosmic bubble that overlaps with ours, but would also include vast regions of space we will never know, and would exclude regions that are familiar to us. The observable universe isn't the universe, it's just our precious personal slice of it. And what a slice it is! Home to an estimated 2 trillion galaxies, each containing hundreds of billions of stars. It's not a prison, it is a gift, a slowly expanding gift that lets us see deeper into the story of the universe with every passing day. When we look up at the silent, star-dusted night sky, we often feel as though we're seeing the universe as it is right now, a live, real-time snapshot of the cosmos. But that isn't quite true. In fact, it isn't true at all. What we are really seeing is the universe as it was. Every star, every galaxy, every faint wisp of a nebula is a time capsule. The light from these distant objects has traveled for so long, across such immense voids, that by the time it reaches our eyes, we're seeing the object not as it is today, but as it was when the light began its epic journey. Looking out across the universe is like rummaging through a cosmic attic, with each deeper layer of light taking us farther and farther into the past. Let's start with a light year. It is a measure of distance, not time. It's the distance a particle of light travels in 1 year, a staggering, almost unimaginable 10 trillion kilometers. The light from our own sun takes about 8 minutes to reach us, so when you feel its warmth on your skin, you are feeling the warmth of the sun as it was 8 minutes ago. If the sun were to suddenly vanish, we wouldn't know about it for 8 full minutes. Now, let's go a little further. The nearest star to our solar system, Proxima Centauri, is about 4 light-years away. The light we see from it tonight left that star 4 years ago. It has been traveling through the silent dark that entire time, just to end its journey in your eye. When you look at a bright star in the constellation of Orion, a star like Betelgeuse, you are seeing light that is over 600 years old. That light began its journey to you around the time the Renaissance was just beginning in Europe. Now, stretch that idea across the cosmos. The light from the Andromeda galaxy, our closest major galactic neighbor, has been traveling for 2.5 million years. We see it as it was when early human ancestors were first walking the Earth. The light from the most distant galaxies we have ever observed with the James Webb Space Telescope began its journey over 13.4 billion years ago. The universe was just a toddler then, a few 100 million years old. That ancient, tired light raced through an expanding universe long, long before our own solar system had even begun to form from its swirling cloud of gas and dust. This is what astronomers call look-back time. We are, in a very real sense, seeing ghosts. We are seeing echoes of what once was. We see ancient galaxies frozen in the early chapters of their lives. Some of the stars and galaxies we see in our deepest images may not even exist anymore in the form we are seeing them. They may have merged with others, fizzled out, or been torn apart by cosmic forces billions of years ago. What we see is a cosmic fossil record, written in photons. But it gets even more fascinating. As that ancient light travels through the expanding universe, our rising loaf of raisin bread, it gets stretched. This is a crucial idea, and it's called cosmological redshift. Think of the sound of an ambulance siren. It is a familiar, simple phenomenon. As the ambulance races towards you, the sound waves are compressed, and the pitch of the siren sounds high. Then, as it passes you and moves away, the sound waves are stretched out and the pitch drops, becoming lower. Ooh. The very same thing happens to light. As a distant galaxy is carried away from us by the constant expansion of space, the waves of light it emits are stretched out along their journey. This stretching shifts the light towards the longer, lower energy end of the spectrum. It shifts it toward the color red. By measuring the amount of this red shift, astronomers can determine not only how far away a galaxy is, but more importantly, how long its light has been traveling to reach us. A high redshift means a very distant object and a very ancient glimpse into the early universe. Every color-shifted photon is a little messenger from the distant past, and its color tells the story of its long, long journey. This makes our telescopes true cosmic time machines. A simple backyard telescope might show you Jupiter's beautiful cloud bands as they were 40 minutes ago. A large observatory on a remote mountain can show you a brilliant quasar as it appeared 10 billion years in the past. And the great observatories like the Hubble and the James Webb Space Telescope are designed specifically to be the most powerful time machines ever built. They are engineered to peer so far back in time that they can capture the faint, flickering, heavily red-shifted light of the very first galaxies to ever form, to witness the cosmic dawn. It is a beautiful irony that to understand the future of the cosmos, we must spend our time staring deeply, patiently, into its most ancient past. The universe we experience is always a little out of date, like watching a film with scenes arriving beautifully, poetically out of order. But this delay is a profound gift. It allows us to see different stages of cosmic evolution all at once, like pages from a grand history book scattered across the sky for us to read at our leisure. So, as you rest here, remember that you are living inside a magnificent museum, a museum made entirely of light, and you don't even have to walk from exhibit to exhibit. The photons come to you. They cross unimaginable distances and spans of time just to tell their stories, just to fill our sky with ancient news from the dawn of everything. There is a quiet poetry in knowing that every time you look up, you are gazing into a time machine.
Not so very long ago, in the grand timeline of human thought,
The universe was believed to be a steady, stately, and eternal place. It was thought to be, for the most part, unchanging. Galaxies were out there, stars were shining, and everything, more or less, stayed put. It was a quiet, majestic, and deeply comforting idea of a cosmos that had always been and would always be. But in the early 20th century, from a lonely mountaintop observatory, under the cold, clear light of distant stars, a discovery was made that gently shook the foundations of everything we thought we knew. The universe, it turned out, has not been sitting still at all. It is in motion in the most profound way imaginable. It was the astronomer Edwin Hubble, peering through the eyepiece of his powerful telescope night after patient night, while studying the faint smudges of light that he knew to be distant galaxies, he began to notice something peculiar, something consistent. He saw that their light was almost always red-shifted. That stretching of light we spoke of earlier, that telltale sign of an object moving away from us. This meant that nearly all of the galaxies he could see were receding, flying away into the cosmic darkness. But even more than that, he discovered a remarkable, undeniable pattern. The farther away a galaxy was, the faster it seemed to be moving away from us. This wasn't a random coincidence. It was a fundamental law of the cosmos, written in the ancient light of 1 billion galaxies. Space itself, it seemed, was expanding. Now, this is a very important and very gentle distinction. This is not the same as galaxies blasting through a static, pre-existing space like cosmic cannonballs. It is not an explosion in space. It is an expansion of space. Let us return one last time to our warm, fragrant loaf of raisin bread rising in the oven. The dough is spacetime. The raisins are galaxies. As the dough bakes, it expands in every direction. The raisins are not crawling through the dough. They are being carried along by the stretching of the dough itself. From any raisin's point of view, all the other raisins are moving away. This is how our universe works. Galaxies are being carried away from each other as the very fabric of space between them stretches and unfurls. This is why, no matter where you are in the universe, it will always look like everything else is moving away from you. There is no center to this expansion, and there is no edge it is expanding from. The universe isn't expanding into anything. It is the expansion. This profound idea forced even Albert Einstein to reconsider his own work. He had originally added a factor to his equations, the cosmological constant, to force the universe to be static as he and most others believed it must be. Upon hearing of Hubble's discovery, he famously called this his greatest blunder. Though in another of the universe's gentle ironies, a modern version of that constant is now our best explanation for the dark energy that is accelerating the expansion today. But the most beautiful consequence of this discovery is that it allows us to rewind the cosmic clock. If everything is moving apart now, it must mean that in the past, everything was closer together. Much, much closer. If you trace this backwards and backwards and backwards for billions of years, everything, all the matter, all the energy, all of space itself converges into a single point of unimaginable density and unimaginable heat. This leads us to the idea of a hot, dense beginning, the event we now call the Big Bang. This wasn't an explosion in a pre-existing void. It was the sudden, rapid expansion of space-time itself, everywhere, all at once. It happened right where you are now. It happened across the street. It happened in the most distant galaxy you can imagine. It happened everywhere. And that expansion, a gentle cosmic exhalation, is still going on today. And so we drift back to our first simple question, the one that set us on this journey. Where does space stop? We have drifted through starlight and space-time, across horizons of light and into the realm of pure wonder. And we find that the question itself may be the answer. Space may not stop at all in the way a road ends or a wall is met. Perhaps it simply continues forever. Or perhaps our universe loops back on itself so that if you traveled in a straight line for long enough, you would end up right back where you started. Perhaps our universe is just one bubble in an infinite foam of other universes, each with its own laws, its own story. Perhaps the ultimate boundary is not of distance, but of understanding. And even that is a horizon that expands with every new discovery, every quiet question asked in the dead of night. I hope that wherever you are, nestled in your own small, precious corner of the cosmos, you feel a little closer to the quiet wonder of it all. I hope your thoughts have softened and your body has found its well-deserved rest. And if you are still awake, just barely, I hope you have found a little peace in the vastness of the asking, even if the final answer remains just beyond the reach of the starlight. Because that is what space gives us, not just silence and stars, but the quiet permission to ask the biggest questions of all, and the gentle comfort of knowing that we are a small, thinking part of a mystery so grand it may never need an end. Thank you for joining me on this journey. Sleep well and keep supporting the Midnight Scientists. And may your dreams be as vast and beautiful as the cosmos itself.